Here is another exercise. The switch is turned on at t equals 0. We need to find the current I through the inductor. The equivalent circuit after switching is like this. L multiplied di over dt equals UL. It plus UR, which is R multiplied I, equals 0. By applying KVL, we've listed the equation. Its characteristic equation is L lambda plus R equals 0. So lambda equals minus R over L. The general solution of this homogeneous equation is I equals A multiply A to the power minus RT over L. Then we solve the initial value of Ri. We draw the equivalent circuit before switching. To analyze the circuit before switching, pay attention that the inductor is short in a steady state before switching. I0 negative equals US over R1 plus R equals I0 plus according to switching law. Substitute it into this equation. When t equals 0, US over R1 plus R equals A. So, I equals US over R1 plus R multiply e to the power minus RT over L. Similarly, the time constant for LR first-order circuit is defined as L over R. By analyzing, you will find its dimension is second to. So, I equals US over R1 plus R multiply e to the power minus RT over L. It's of great advantage to define the time constant for LC and LR first-order circuit as RC and LR respectively. One advantage is we can use the same e to the power minus t over tau to represent a decay. Another advantage is here. This is the expression of the current through the inductor, in which I0 equals US over R1 plus R. It's 10 before switching. It tends to 0 when t tends to infinite after switching. The negative exponential term decays to 0. Now we study what's the value of I when t choose different values. In this table, we calculate the corresponding value of this term. When the t equals 0, it equals 1. When t equals tau, it's e to the power minus 1 equals to 0.368. When t equals 2 tau, it's e to the power minus 2 equals 0.135. When t equals to 3 tau, it's e to the power minus 3 equals to 0.05. When equals to 5 tau, it's e to the power of minus 5. What's the meaning? We can find the change of first order is from faster to slow with the time. And the decaying procedure won't over forever. But from the viewpoint of engineering, we find when t is greater than or equal to 3 tau, it decays to 5% of the initial value. When t is greater than or equal to 5 tau, it decays to less than 1% of the initial value. So in engineering, we often thought the whole transient process is finished after 3 tau to 5 tau. This is the second important advantage of tau. The smaller tau is, the faster the transient process changes. You should notice that tau equals to RC for RC circuit and equals L over R for RL circuit. Please think about this question, that Y tau is larger if R or C is larger in RC circuit. And Y tau is larger if L is larger or R is smaller in RL circuit.